Have you ever really stopped to think about what's happening behind the scenes when you hit play on a YouTube video? The scale of it all is just mind-boggling, and the engineering that makes it work is seriously clever. So let's pull back the curtain and see how YouTube pulls off this daily miracle. Let's start with a number, a big one, 500. That's 500 hours of brand new video content getting uploaded to YouTube servers every single minute of every single day. And at the same time, over 2 billion people are watching stuff. That's not just a big number. That is a monumental, flat-out engineering challenge. So, how on earth do they do it? How do you process, store, and stream that unbelievable amount of data to you, me, and billions of other people without the entire system just collapsing? Well, that's the puzzle we're going to piece together. To really get it, we're going to follow a single video on its epic journey. We'll start from the moment a creator clicks upload and follow it all the way until it appears perfectly smooth right on your screen. It really all comes down to 3 main phases. First, the video gets uploaded and processed. Second, it's stored somewhere safe. And third, it's delivered to you, the viewer. Sounds simple enough, right? But trust me, underneath each of those steps, there's some incredible technology at work. So now, let's uncover the engineering secrets that make it all possible. Okay, so behind those simple steps are 4 key engineering concepts. This is the secret sauce to YouTube's success. This stuff is what makes all the magic happen. Secret number 1 is called transcoding. You see, when you upload a beautiful 4K video from your phone, YouTube doesn't just store that one gigantic file. Nope. Instead, its servers immediately get to work on a huge computational job, creating a whole family of copies. So why go to all that trouble? Honestly, it's all about you, the viewer. Transcoding makes sure that whether you're on a slow mobile connection trying to watch on the bus, or you're at home on a super fast connection with a massive TV, there's a version of that video that's perfectly optimized for your exact situation. Okay, so now we have all these different video files. Where do they all live? Well, that brings us to secret number 2, distributed storage. Your video isn't just sitting on a single hard drive somewhere in California. It is duplicated and stored in Google's massive data centers all across the globe. And this strategy gives YouTube 2 huge advantages. First up, reliability. If a data center in Europe has some kind of problem, servers in Asia or America can just seamlessly take over. You would never even know. And second, speed. By storing a copy of a video in India, viewers in Mumbai get way faster loading times because the data has so much less distance to travel. But they take that speed thing one giant step further with secret number 3, the Content Delivery Network, or CDN. Think of this as the final leg of the race, closing that last bit of distance between the video file and you. The analogy here is perfect. Instead of one massive central warehouse, imagine having a small local warehouse in every big city. A CDN does the exact same thing for video, placing copies of popular stuff on servers that might be just a few miles from your house. Less distance just means less lag. And now for the final secret, the one that prevents that dreaded spinning buffering wheel. It's called adaptive bitrate streaming, or ABR. This is the intelligence that's built right into the YouTube player itself. So let's say you're at home with a great Wi-Fi connection. The player on your phone or laptop, it can sense this. And so it asks for that beautiful, high-quality 1080p or even 4K version of the video, one of the copies that got created way back during that transcoding step we talked about. But what happens if you walk into another room and the Wi-Fi signal drops? Well, the player detects that change in your internet speed almost instantly. And before you can even notice there's a problem, it automatically switches from that 1080p stream down to a lower quality one, something like 480p. The result? The video just keeps playing smoothly, no buffering. That seamless switch is adaptive bitrate streaming in action, and it's absolutely brilliant. So when you put all these pieces together, you really get the fundamental principles that allow YouTube to operate on a truly global scale. You can think of it as a toolkit for building any massive media service. You've got transcoding to prepare the content, distributed storage for safety and speed, CDNs to bring it local, and ABR for that smooth playback. And underneath it all is something called horizontal scaling, which is a fancy way of saying they can just keep adding more and more servers to handle billions of users. This is the blueprint for planet-scale streaming. It really makes you think, doesn't it? That seamless experience we all take for granted isn't magic at all. It's just incredibly clever system design. And it kind of begs the question, what other parts of our digital lives feel like magic, but are really just elegant solutions to massive engineering problems?